we will be starting a new question. The question is like this: integration of log x, log and in bracket log x divided by x dx. Okay, so we have to write. This is equation number 1. We will be writing I integration is equal to. Okay, integration is equal to same the question we will be writing once again. We have repeated the question over here, and now we will be proceeding further. Okay, so this can be done only through substitution method. So we will be putting some kind of alphabet. For log x we will be putting z. Okay, so z is equal to log x, that is our substitution. Okay, and then we will be differentiating that, differentiating dz. Okay, z with respect to x. Okay, that is dz, and log x, if you take differentiation of that, you will get 1 by x. Okay, so log x is 1 by x. And now you see the question, when you see the question, you have something in common out here. You can see, I'll circle that. This is x, okay, dx, and this is x. So you can see this dx has to be taken from here in the denominator to here in numerator. So that is the reason why dx is taken to the numerator. And if you see, it is 100% matching the equation number 1. So now what we need to do, we have to put these values in equation number 1, and our equation will get transformed. Equation 1 will get transformed. I is equal to integration of log z dz. Now if you see clearly, since there is no number over there, so here we will be putting 1 as a number. So 1, even if you put that number 1, the value won't change. So we are putting this log z into 1. Okay, we are putting that. Why we are putting, I'll just tell you right now. Okay, I is equal to integration of log z into 1 into dz. So one we will be considering as u, and one we will be considering as v. So one d log z we will be considering as u, and v will be considering as 1. Now proceeding ahead, what we see is that uh, when you see log z and the 1, you see the log z and the 1 out here. Log z is u, okay, and 1 is v. So we have to take this integration of u into v into dz. But we need not confuse that with the derivation. So derivation is completely different and integration is completely different. So I wanted to show you, this is derivation, what I have marked over here. Okay, this is derivation, but this is wrong. Okay, we have to do integration. So in integration, what we need to do is that u into v into dx. Okay, integration of u into v into dx. So you can see u is outside the integration and first time, integration of v dx minus a bigger integration sign, bracket open, the same this symbol will come over here. Okay, so this is the integration of v dx into derivative of u into dt. Okay, so this is the right equation, this is the wrong equation. Since this is differentiation, this is not applicable over here, this is applicable. So you compare with this equation, you will see this equation has been transformed. Our main equation has been transformed to, you can see, log z is u, integration of 1 into dz, okay, that is this part. Now minus the bigger integration, okay, the smaller integration, this part is continued over here, okay, this part is continued over here after integration, after putting a bracket, and d by dz of u, this is our u, okay. So these three circles you need to be very careful, and the dz, last bracket close, and the dz part, okay. Once you have done that, everything will be simple. You have to do integration of 1 into dz is dz itself, and you will get is z itself. So you have got z over here, and log z into z, okay. Then integration of here, this integration of dz is dz itself, and integration of that you will get z, and this derivative of log z would be 1 by log z. So this z and z will get cancelled, okay. So you will get 1 as the answer. You have got the answer 1, okay. So that is how you got the answer 1, and this minus sign would be there, and this log z into z, okay, integration. So this would be dz, okay, integration of dz minus log z, okay. So now integration of dz is z itself, okay, plus c you have to put, and then z into log z, So now we have been stuck. So what we need to do is that we are not able to proceed further. So what we will be doing is that we will be resubstituting the value of z what we have put earlier. We will be putting that once again. So instead of z you will be putting log x. So wherever z is there you will be putting log x, and z is there you will be putting log x, okay. Here also z is there, you will be putting log x. So the final equation is log x is common, you can see both the sides. So here log x over here and the log x over here are common. So that is the reason we will take log x as common, and inside the square bracket what is left is log x into log x. This is, since that log x is gone on top, minus 1 is there, remainder bracket close plus c. So this is the final answer. So this is your final answer. Now we will be moving forward with our question. Okay, our question is like this. Question. This is our question. Integration of x square under root a square minus x raised to 6 dx. Okay, that is our question. So seeing our question, so we had read this question part, so we have to write this as integration form. So we have written I is equal to integration of x square under root of a square minus x raised to 6 dx. So that is our question. So we have written that in integration form. So I is equal to, now what we need to do is here, this x raised to 6 is there, that we need to split up. X raised to 6 we have to split up. So x raised to 6 we have to split up. We have to split it like this. 3 2s are 6. So x cube into the square outside. So in this way we can split x raised to split x raised to 6, and we have to give that equation as equation number 1. So our equation number 1 is I is equal to x square, okay, x square under root of a square minus x cube the whole square, okay. Under root, the under root is over, now outside under root is dx, okay. Now what we need to do is that we can solve this by now substitution. So substitution, you can see we can put any alphabet. I put z is equal to x cube. So now differentiating with respect to x, so this becomes dz, and this after differentiation will become 3x square. Okay, x raised to n formula, and n will come before x. So here n is 3, and x raised to 3 minus 1 you will get 2. So that is how you got this. And now you need to see the question. Once you see the question, you will come to know there are two terms in question. One is x square is there and dx is there. So since dx is down over here, you will be taking it to the opposite side. It is division here in the denominator. One goes to the numerator on the opposite side, and the 3 is not required, so that 3 is brought down. So that 3 is brought to the denominator in the opposite side of the equal to. Okay, in this way we have arranged. So these two values you need to keep in mind, these two values, and these two values you need to substitute in equation 1. So substituting all the values in equation 1, equation 1 is transformed like this: I is equal to integration of I is equal to integration of, now I'll read that this I is equal to integration of a square minus z square into dz by 3. So this dz by 3 you have got it from here, here. Okay, so dz by 3 instead of x square dx, you will be putting dz by 3, and here already you have the values, and this value you put it over here. Okay, so these are this is how the equation 1 got transformed. So equation 1 has been transformed, and now you can see dz by 3, there is 1 by 3. So that 1 by 3 we have brought it outside the integration sign, since it is a constant. So once it is brought the outside the integration side, you will get this integration of a square minus z square into dz. So according to this formula, you can see the formula over here, a square minus z square is exactly matching this. Okay, so a square minus z square, now it is in the form, and we can use this formula. This formula we have done couple of times. Integration of a square minus x square dx, so equal to x divided by 2, okay, under root of a square minus x square, a divided by a square by 2, sine inverse, okay, sine inverse of x divided by a plus c. So this formula needs to be done properly. Once you do that formula, we'll come to know that we can proceed further. So according to this, you can see according to this formula we had reached over here. So according to this formula we had reached over here. According to this formula, our equation, the above equation gets transformed. This side get transformed. 1 by 3 will be constant outside. You can see 1 by 3 is constant. We are talking about this whole term. Okay, this whole term has been changed. So this whole term you can see one by one. I'll try to explain. So instead of x we have put z over here. Instead of x we have put z. Instead of x we have put z. So first difference is that. Then you can see the a part. Now you see the a part. So this a is over here. This is the a part. This is the a part. This is the a part, and in the denominator there is a. So these a's you need to be careful about. So now I'll read this side. This side has been changed. This is constant. So z divided by 2, a square minus z square, a square minus a square divided by 2, sine inverse of z divided by a, and this plus c, okay, which is outside the square bracket. So now this what you need to do is that you can put the final answer in terms of z, you have to put in terms of x. So you have to resubstitute. So this is what we have done. We will be resubstituting the value of x. So z is equal to x cube. So instead of z, you will be putting x cube. Here also x cube is there. Here also x cube is there. 3 places you need to put x cube. So I'll just read it out. I is equal to 1 by 3 z cube divided by 2 under root of a square minus x cube square plus a divided by 2, a square divided by 2, sine inverse, okay, sine inverse of x cube divided by a plus c. So our equation gets transformed. You can see this equation gets transformed. There is a 1 by 2 common over here. You can see 1 divided by 2, 1 divided by 2, both places is common. That is how this 1 divided by 2 has come outside. 1 divided by 3 is already there outside, so it becomes 1 divided by 6, okay, on the outside. And now we will talk about the inside. Once the 1 by 2 goes, this is remainder x cube. Now x cube is remainder. After that under root of a square minus x cube square, and this is a square sine inverse of x cube divided by a plus c outside the square bracket. Okay, this is our final answer. I is equal to 1 by 6 x cube a square minus 6 plus a square sine inverse x cube a plus c. So we have reached, this is the final answer. Okay, this is our final answer. Thank you so much. Thank you for watching. This was the end of the 4th part of the question bank, indefinite integration, the 4th part. This was for 12th standard maths students who are belonging to the science stream. Thank you so much.